Today we're going to talk about rewriting literal equations. Basically what we've been talking about in this chapter is how to solve equations. We've been talking about equations that have one variable, sometimes on both sides, but one variable, where we have all numbers next to them that we use our SADMEP steps to undo the different operations to get to just our variable with the answer. So a literal equation is a little bit different. It's the same idea. It is an equation, and it still is going to involve moving steps in the reverse order for SADMEP, but the difference is a literal equation has two or more variables. So the literal equation is something that has more than one variable. So to rewrite one of these, which is what we're learning about today, what we need to do is solve for one of the variable in terms of the other variables using our SADMEP steps. So we solve the one variable by getting the other variables on the other side of our equation. Remember, we're using SADMEP. So basically what that solve for means, we isolate the variable we're looking for to get it by itself, and all the others go to the other side. So let's kind of see how one of these looks. So here we have an equation, 2y plus 5x equals 6. We want to solve this equation for y's. Now we have two variables there, so we're not going to get an answer that we have a nice number answer. We're going to get an answer that's going to have a variable in it because we have two variables. We're going to solve for one, but the other side is still going to have one. So we're still going to use our regular SADMEP. So if I look at this equation, I see adding, I see some multiplications. So remember, we're trying to get this y by itself. So the things that have to move from the y, well, there's a 2 that has to move away right here, which is connected by multiplication, and then there's also a 5x that's being added to that term. So what we're actually going to do is first we're going to move the 5x. So we're going to take that whole entire term and move it to the other side. We move it by undoing adding 5x, so we get subtract 5x. So what that's going to give us is those cancel, and that's going to leave me with two y's on the left. And on the right-hand side, we got to think about our like terms. I have to have like terms to be able to add or subtract. So we can still do 6 minus 5x. We just can't combine them to make it x, and that's one of the mistakes we got to stay away from. So secondly, now we're still solving for y, and now I just have multiplication there. So we undo multiplication by dividing. And I divide by 2 on both sides. So again, once that's going to help me get is the y that we're looking for on the left. Now on the right, I'm going to bring this over here so we can see this. Remember when you used to look at fractions, we want to break apart this one here, because the easier way I think to do this one is to think of 6 minus 5x over 2 as 6 over 2 minus 5x over 2. So when I have something that has, I'm dividing the whole side by, like this 2, where my terms in my numerator become adding or subtracting, the 2 has to go into both the 6 and the 5x. So if I now can look at those two separately, well, we can do 6 divided by 2, I get 3. And the 5x over 2, there's really not much we can do with this. We don't really have a problem with improper fractions. We like improper fractions. So we're going to leave it just like this because, again, I can't do 3 minus x's. So I don't want to make this combine any further. That's as far as we can go. That is rewriting that equation, solve for y. So next we're going to talk about looking at our formulas. So a formula. So we have formula sheets, we have areas of things, we have perimeters of things, surface areas, volumes. A formula is showing how one variable is related to one or more other variables. If you think about it, formula is a literal equation. A formula would look very similar to what we just saw. You have x's and y's in the same thing. So that's a literal equation, but it also could look very much like our formulas. So we're going to take these two formulas that you will have at least some familiarity with, at least the first one, and we're going to rewrite them so that we can see how they would look in a different way. So the area of a rectangle formula. We know that the area of a rectangle could be looked at as area equals length times width, or in this case we're going to go with base times height. So we're going to rewrite this formula, area equals base times height, solved for b, which means this needs to be by itself. So using our SADMAP steps to undo b times h, I'm going to divide. And this time I'm not dividing by a number, notice that I'm dividing by h. So now we got to look at what does that do for us. Well, h divided by h, any number divided by itself becomes 1. So that cancels, which is what we want. Now b is already by itself. On the other side, a is divided by h. I don't know what a is, I don't really know what h is, so I can't do the actual division at the moment. But for now, we can rewrite our formula. If we had the area and we had the height, we could rewrite our formula as b equals the area divided by the height. So again, as you start moving on forward here, usually if you were given this equation and given the area and the height, you would just plug it in and use your SADMAP steps with all the numbers. But this is just helping us practice with some things that we do know, and this area formula is one that we do know. So on this last example on this side, so now we have the formula of the surface area of a cone. Remember, a cone, and we'll deal with this later this year, a cone is like a pyramid, has a circular base, and then it comes up and meets at a point. So the surface area formula for that cone is S equals pi r squared plus pi r L. We're being asked here to solve for L, which means that's the last thing that we want by itself. So very first thing, again, we see a couple of different operations. I see multiplication, pi times r times L, or pi r times L. Over here I see adding pi r squared. So in SADMAP I would take care of this addition first, and I need to move that to the other side. So I'm going to move that entire term, pi r squared, to both sides. Again, pi r squared minus a pi r squared is 0 pi r squareds. On the left-hand side, there are not like terms there at all. So I can't do anything except just put them next to each other with a subtraction sign. On the right-hand side, pi r L is still there. Again, remember we're trying to solve for the L. So now I see two things being multiplied by the L. So really what I need to do is divide by the two things, the pi and the r, to move it away. Multiplying both sides by pi r. So pi r divided by itself, or another pi r, cancels. That's going to leave us with L. That's what we're looking for, so that's a good sign. And on the other side, we got to kind of see if we can simplify a little bit better. So because I see a minus in between those two, so subtraction, I'm actually going to separate the two terms with the pi r underneath. Okay? We're going to do this a little bit later on, so this is going to be a little bit hard to understand at first. But the next step here, what we're going to do is say, how I can simplify this. Well, let's look at each. S over pi r. There's really nothing I can do with that. There's nothing that's common that I can take out. However, the second one, though, we just kind of said anything divided by itself goes away. Pi divided by pi is a 1. This r squared is another way, if you remember, writing r times itself twice. We're dividing by r. And notice when I divide by r, this r cancels that r, which leaves me with one r left over. So this pi r squared divided by r is basically going to leave me with one r. And again, I would probably want to bring my L to the left-hand side, s over pi r minus the r. That's as far as we can go for now. Can't really add anything further to those. That is my formula rewritten for L's. So here we have another formula, the temperature conversion of converting Fahrenheit to Celsius. It's kind of a crazy looking formula, but it's a way to convert our Celsius from Fahrenheit. Okay? So first what we're asked to do is solve for F. So to solve for F, now we've got a fraction involved that we've got to figure out how to deal with. So because I have a grouping in here, and I have multiplication out here, if I think about my groupings, that is my P in SAD MEP, so that's going to be last. The multiplication is going to be what we take care of first. So to take care of that multiplication, I need to divide by 5 over 9. Okay, so when I divide by 5/9, remember C divided by 5/9 becomes C times the reciprocal 9/5, so 9/5 C. Now on the right hand side, notice that we are dividing by the 5/9 to everything, but also notice that the 5/9 is times the group. So because it's times the group, I don't need to separate those two terms up at the top like we did on the last one. All I need to do is divide this 5/9 in once, and notice that that cancels. So that is now going to allow me to bring down what's in the group, F minus 32. So from here, still trying to get the F by itself, so I'm going to add 32 to both sides. And we'll bring our answer over to the right-hand side here. So on the left-hand side, 9/5 C plus 32 equals the F. I can't combine the 32 with the C's. And then my last step here, again, we like to see the variable on the left, so I want to bring the F over. Because it's an equation, I can just flip the two sides, and that is the formula solved for F. So now we want to use this formula, okay, for this real-life equation. We're trying to convert from Fahrenheit to Celsius, so we're given that formula. We're going to use this formula to determine which of the sun or the lightning has the greater temperature. And we're going to kind of add in here that we want to know in degrees Fahrenheit. Okay? So in degrees Fahrenheit. So basically we're going to use the formula from example 3. So we determined that the Fahrenheit temperature is 9/5 C plus 32. So basically what we are doing is we're converting the lightning to degrees Fahrenheit, and then we can compare. We want to have them both the same so we can compare them. So the Fahrenheit of the lightning is going to be 9/5. The Celsius is 30,000. And then we're going to add 32 to that. Calculator is going to come in handy on this one for sure. And I'm going to get 54,000 plus 32. Now we're just following our regular PEMDAS here because we're not solving for a variable. We've plugged in our numbers and we're just going forward. So we get 54,032 degrees Fahrenheit. So lightning has a greater Tim. 54,032 versus 11,000 for the sun. So some of these are things that you're not really ever going to use in a real life situation. Understanding how they work and how to move equations and variables around is really what this section is all about. We're going to be doing an awful lot of times where that's going to happen, and we need to be able to understand how to work when we have more than one variable. So being able to solve for one variable is great, but we also need to be able to solve for one variable when there are other variables in them. So it's not necessarily a skill that you're going to use a lot as far as, oh, I'm going to make a literal equation before I solve this. There are a lot of times, though, that we have to understand how to move numbers and variables from each other, especially when there are more than one of the variables. So it is definitely an important skill to learn and to understand as we work through this year, and then also when you get into Algebra 1.